I'm sorry. All right.
Do what she wants to do.
So today we are solving by completing the square. Completing the square is a process that we're going to use to solve quadratics. We did it by graphing, we did it by solving equations. Now we're going to have another way to do it. So completing the squares, we're going to be making perfect squares based on a perfect square trinomial. So to complete the square for an expression, we start with x squared plus bx. And that comes from the standard form of our quadratic, so that ax squared plus bx plus c. We're just using this piece here to use to start completing the square. And I laid out the steps that you do. Your first step is whatever your b term is, you find half of it. So that's the same thing as you put that into like math. That's dividing b by 2. Or multiplying it by 0.5. Your next step is whatever you got in step 1, b divided by 2, that's going to give you a number. Whatever number you get out here, you're going to square it. So b divided by 2, you're going to square that. b divided by 2 squared. And what we're doing is we're making a c term. If we see right here, we just have x squared plus bx. We don't have a c. We're making our c term, and our c term is going to be a perfect square. So for our last step, we have to add a result from step 2, so this number to both sides. Or at least for here, at least we don't have both sides right now, so we're just adding it. So you would write their last step, we would look something like bx, x squared plus bx plus whatever we got out in step 2, which it would be b divided by 2 squared. So this term right here is your c term. And this is going to make a perfect square trinomial that is perfect square trinomials are easy to factor. So that's why we're doing this. And that'll be your last step. We're going to do some more factoring, going back to using our x method like we did in chapter 7. So your first example, your notes are laid out exactly like the homework. I don't know. You're going to have to copy it at the end or copy it for someone else.
When like 5 other people told me to wait.
You guys got to keep up. That's part of taking notes. I'm not going too fast.
You're not being a good teacher.
I'm going at the speed that I think is appropriate. So if you can't, you can go back and look at the notes key when we're done. Right? Or I could talk for 45 minutes. So the steps to solve. We have x squared plus bx plus c. Your first step is to find out what your b term is. Your b term is 6. So I'm just going to put a little b above there. And then we take 6 divided by 2. That's your first step. 6 divided by 2 is 3. And we take the result and we square it. So we're squaring 3. So 3 squared, 3 times 3, that gives us 9. So that's all the steps of completing the square. So your c term is equal to 9. And the first section of notes, that's all we're doing. On the first section of their homework, all you're going to get out is answers for C. So our numbers aren't always going to be whole numbers. So if we look at example B, we would take -9, we would divide that by 2. So divide our B term by 2. That's -4.5. And then we take the result and we square it. So we have -4.5 squared, which is equal to 20.25. So that's our C term. Your final answer, you write C is equal to 20.25. Keep going forward. These again, we're just practicing these types so we can get some practice because we have to do this as we get kind of our problems become more in depth. Our B term is 10, so we take 10 divided by 2. That's 5. Then we square results, so we're squaring 5. So 5 squared is equal to 25. So our C term is 25. For the last problem, if you want, you can try it on your own. Figure out what your C term is. Just always the same 2 steps. Divide by 2 and then square your result. Negative 14 divided by 2 is negative 7. One thing you have to be careful of if you're using a calculator, that when you're squaring negative 7, it needs to be in parentheses. So negative 7 times negative 7 is 49. So your C term is equal to 49. So each time we found C, they were perfect squares. And that's going to help us in our next step when we have to end up factoring these, because it's a lot easier to factor a perfect square than anything else. All right. So instructions for the second set of examples are the same instructions that are on your homework. You're going to complete the square, so that means you're going to find C, and then you're going to factor the trinomial. So I'm going to figure out my C term. I'm going to do it in my head. All right, so to find my C term, I'd have to divide negative 12 by 2, because negative 12 is my B term. So that'd be negative 6. Then I square negative 6, so I get 36. And 36 is a perfect square, so that's good. What I'm going to do now is rewrite this with plugging in 36 for C. So x squared minus 12x plus 36. And from here we have what's called a perfect square trinomial that we can factor. When we factor this out, our 2 factors, or our 2 parentheses, are going to be the exact same. So when we have 3 terms, we always said how to factor, you set up your x. On the top, you take your A times your C term, so that's 1 times 36. So a 36 will go on the top, and a negative 12, your B term, will go on the bottom of your x. And you're looking for 2 numbers. So when you multiply them, it's 36. When you add them together, it's negative 12. Well, to get to 36, I know that's 6 times 6, but I need to add to a negative 12. So that's going to be negative 6 and negative 6 on either side. And then since our A term is 1, I can factor this quickly. I could say that this would be factored. I could use x minus 6 and x minus 6. So this is why I said in chapter 7 that factoring is going to come back. It's going to stick around to the end of the year. Here we're doing it again. We're going to simplify our answer. So instead of writing this as 2 terms, we're just going to write it as 1 term. So we can simplify, instead of writing x minus 6 and x minus 6, we can write x minus 6 squared. And that's how we're going to express our final answer. So in section 2 of your homework, those 4 problems, you should be having something in parentheses squared. All right. Pause for another second, then we're going to move on to the next one. If you're comfortable, you can start the next one on your own. You can try doing that. All right, to find your C term, we had our B term is 4, so we divide 4 by 2, which is 2. then we square 2, so 2 times 2 is 4. So now our c term has to be 4. We plug our 4 back in for c, so you can write this as a trinomial. It will be x squared plus 4x plus 4. And then we'll factor. So set up your x to factor. On the top of your x is your 4. On the bottom of x is a 4 too. So you need two numbers that multiply to a positive 4, but also add to a positive 4. So the only number that's going to work is 2 and 2. So whenever you're completing the square, and you get to this factoring step, these two numbers on either side will always be the same. If you have to use two different numbers, you're not doing it right. These will always, always, always be the same two numbers. Because what that does is it makes something like this. And that's what we want, because we're going to use that in our next step. So this would be x plus 2, x plus 2. So we're going to write that as x plus 2 squared as our final answer. All right. The last two examples, we're going to put those kind of two previous examples together, finding our c, then factoring. And now we're going to throw in our steps for solving using square roots. So just like I said when we started, that all we need to start completing the square is this x squared minus bx. It can be set equal to 0, or most of the time will be set equal to a number. This is okay. This minus 15 over here is okay. We're just going to start with what's highlighted and complete the square on our left-hand side. So that would be, we'd have to find our c term. We would split 16 in half, so 16 divided by 2, or negative 16 divided by 2, is 8. And then we have to square 8. So you get out 64. So on our left-hand side, completing the square would give us x squared minus 16x. Then we have a new c term. This is plus 64. We rewrite out what we still have, equal to negative 15. But the big thing, and this is a lot of people miss this, so don't fall into this trap. If I add 64 to this side, since it is an equation, I have to add it to the other side as well to keep my equation balanced. So I also have to put a plus 64 over here. If you do something to one side of the equation, you have to do it to the other as well. So now I'm going to keep looking at just my left-hand side. I'm going to factor that trinomial. I'd have a 64 on the top, a negative 16 on the bottom. So on either side, I'd have negative 8 and negative 8, because that multiplies to a positive 64, but adds to a negative 16. So negative 8, negative 8. So this would be x minus 8. And we simplify, we take negative 15 plus 64, so on the right-hand side here, we get out 49. Just by adding those two numbers together. So like we did in our last two examples before this, we're going to rewrite this as just one term squared. So rewrite this here, just take this and turn it into x minus 8 squared is equal to 49. And again, the instruction said we're trying to solve for x. So we're trying to get x by itself on one side. So now this goes back to 9.2, which we started last week. To undo a square, we have to take the square root of both sides. So your next step is always going to be take square root of two sides. We take the square root of this side, we're just left with x minus 8. When we square root 49, we're left with, it could be either positive 7 or negative 7. Because 7 times 7 is 49, and negative 7 times negative 7 is 49. Whenever you take the square root of a number, it should be a positive, there's a positive, and there's a negative. So we write that as plus or minus, and you could do like the symbol, plus or minus 7. So you may think we're done, but we're not, because we can get we're always going to get out two answers, and we get two exact answers for x. We can complete another step to get x by itself. We could add 8 to both sides. So add 8 and add 8. So this is how you're going to write it. You're going to say x is equal to 8 plus or minus 7. What that plus or minus means, a lot of people overcomplicate it. It means one time to figure out for x, you're going to do 8 plus 7. Then you'll do it another time, but instead then you'll do 8 minus 7. So then you're going to get two answers out for x. X is equal to 15, or x is equal to 1. Yeah. Yeah. Because you were to plug either 15 or 1 into your original, they would both sides would equal each other. Yeah. All right. Just last hour, a lot of people are confused by this plus or minus. Big thing is, anytime you take a square root of a number, it's always plus or minus that number. And then when you get your answers for x, you just do it 8 plus 7, and then 8 minus 7. One with addition, the other with subtraction. All right, so we'll do one last problem together, and then you have work time. This problem is set up a little differently than the previous one. Here we have a C term, 17, but it's not, 17 isn't a perfect square. So really, I just want this piece by itself so I can make my perfect square. So I'm going to subtract 17 from both sides to start. Minus 17, minus 17. I'm making the C term that I want. Not the C term that's given to me, the C term that I want. So it'll be x squared minus 18x is equal to negative 17. So now we're left with just our x squared minus bx. So we can go through, just like we did in our last problem. This setup now looks exactly the same as our setup in example A. You can go through, make a new C term to complete the square, go through and factor and solve for x. So your C term off to the side here, negative 18 divided by 2 is negative 9. Negative 9 squared is 81. So your C term is 81. So we can write now our left-hand side out as x squared minus 18x plus 81 is equal to negative 17. And again, if we add 81 on this side, we have to add 81 on the other side as well. We have to keep our equation balanced. So whether you need to like circle it, underline it, whatever you need to do to remind yourself, do it to both sides. All right, so now we're kind of moving into the factoring step. We have to factor this trinomial. We'd have an 81 on the top, a negative 18 on the bottom. So 81 we can get from taking 9 times 9. We have to add to a negative 18, so it's negative 9 and negative 9. So we can write our left-hand side out as product of two terms, x minus 9. X minus 9 is equal to 64. And then we just keep simplifying. So you can set up to solve this. This is x minus 9 squared is equal to 64. I'm going to start square rooting each side now. 64 is a perfect square, so that'll be easy. On my left-hand side, I'm just left with what's inside the parentheses. So x minus 9. And the square root of 64 is either positive 8 or negative 8. So write plus or minus 8. And my last step, before I get my two answers for x, would be to add 9 to both sides. So plus 9, plus 9. So I'd say x is equal to 9 plus or minus 8. So again, that just means you're taking 9 plus 8. So x could be equal to 17. And then you're taking 9 minus 8. So that would be 1. So you're always, unless you get no solution, you'll always have two answers for x. They can both be positive, they can both be negative. One can be negative, one can be positive, it depends.